This video is on beginning to work with Python. We'll talk about geoprocessing with Python, why this course uses Python, where to write code, and how to get input into scripts. And finally, we'll go over some basic Python code components. Let's start with the in-class exercise, Simple Buffer. So the idea of this exercise was to see how to use Python, the Python window, to get immediate feedback, to run Python geoprocessing statements in the interactive window, and to understand the connection between Python code and ArcGIS tools. So let's go over to the web page where we have the instructions. This can be reached by going to the schedule and then the in-class exercise for that day, and we go to the first exercise, which is Simple Buffer. So the instructions are to get the data, the sample data, into the right location. So we get this GIS540 zip file and download it and put it on the hard drive. And then we need to confirm that this shapefile exists, because this is going to be our input for this example. So if we go to the GIS540 directory, we can do this as a shortcut, and we find that path is correct. There's no double GIS540 in there. And so if you do have that, it's probably a unzipping problem. Okay, so now we can go into ArcMap and just start with a blank map, and I'll show you how this window is opened. Just click here, and that brings up a Python window. I'm just going to throw this one over to this side. And we have our instructions over here in Chrome. So the instructions say, go ahead and become familiar with the Python prompt. This is the Python prompt, these three greater than signs, and there's help relevant to whatever you're doing in that prompt over on the right window here. So the first thing we're supposed to do is type print hello. Notice that I use double quotes, and this uses single quotes. Either one is acceptable. And that prints out the word hello without the quotes around it. And we can also use Python as a calculator. Notice it doesn't matter if there's a space between the 5 and the plus and the plus and the 6. That's okay. And then we can set x. So let's first try printing x. We print x. Whoops. Name error. Name x is not defined. That's because we haven't told Python what it is yet. Now we're going to tell Python what x is. And if we say print x, it prints out the number 5, because that's a value that it has behind that variable. And then if we say just x, we type just x and hit return, we also get 5, because in this interactive window, when you put a variable into the window and hit return, even without the print statement, it evaluates the variable and returns the value prints the value out in the line below it. So now we can move on to the step 5, which is copying the line of code that's here. And if you would like, think about what you think this line of code is probably doing. We'll come back to that in a minute. Next, we'll enjoy number 6, and then we'll move on to number 7, which is copy these lines of code. Notice that there is code all the way out to over here, and it wraps around. You have to get both lines of code at the same time. Copy and paste those into the interactive window. And think about what you think this is going to do, what the result of this statement is going to be. What could it, since the exercise is called Simple Buffer, you might guess that this is going to produce a buffer file. So we got some results over here. I squeezed this down a little bit too much to see the results. But it's telling us that it ran the buffer tool. And as you see, the buffer output is brought up to the map automatically. We can make our output look like the output that's shown in this image by adding the park data to the map, and of course the colors are randomly assigned, so that doesn't make any difference. So now what do you think will happen if you try to run that command again? In order to run, you can run code that you've put in before. You can use the up arrow and go to the previous command or commands before that. You can print X. I can try and do this. This is calling the buffer tool. You can try to do this again, but it complains because the output data already exists. So if I were to want to run this tool again, the way the code is, I would have to go in and delete park buffer and then run the code again. And of course, we'll learn about overwriting output with Python in a little bit. So you may have guessed by now that this line of code is very much like using the Arc toolbox to run a tool. It's very much doing the same thing. And we have an example of the GUI from Arc toolbox. If we go back to the slides, we can address this question about what are the differences between what's shown in this GUI and what is shown in the line of code that's calling the buffer tool. And these are just differences that are there to show you, to draw your attention to the fact that each of these fields that are in the graphical user interface, the GUI, correspond to one of the elements that's assigned, that's given a value when the tool is called in this example. So we have code. Did you figure out what this one is doing? This is setting the working environment for the Python ArcPy. And ArcPy is our way to interact with ArcGIS tools and other elements. So here we are. We have set this workspace, which means that we can just simply say park.shp, because that's the directory where the park shapefile is. So that's one difference. The input features are specified first here, but the input features that are specified over here have the full file path for the park shapefile. Now, if I tell you that the next line has the output feature class specified, maybe you'll notice that there's a difference between the output feature class name and path and the one that's specified down here. Also, this is telling the tool how big the buffer should be. So this is a 1/4 mile and this one is a 5 mile buffer. Next we have the side type, which we're using outside only in both of these, and the in type, and we're using round here and round the default there. Finally, we have the dissolve type, and this call that we use in the Python is dissolving all, and versus this, which has none. So we found 4 differences, and those are again repeated in the slide notes. Python can be used for geoprocessing in several ways. So for geoprocessing, you know already that you can use the tool dialog, the graphical user interface. You can also, now you've seen that you can use that Python command line. fact, you can also use the Python scripts in the model builder models. They can be inserted in there as part of the model, and model builder models can be exported as Python scripts. So that Python is really well integrated with Arc Toolbox. Why are we using Python? Well, one of the reasons is that it's installed with ArcGIS 10, and lots of examples are given. It's a great way to work with ArcGIS. The other reason is, and the reason that ArcGIS is using it this as well, is that it's a good starter language. You can easily automate tasks and perform batch processing. You can also schedule processes, and the syntax for Python is intuitive. If you look at this example over here of JavaScript versus Python, Python's doing basically the same thing that JavaScript is doing in 14 lines of code. Where should code be written? You can write Python code. You can write code in any text editor. It can be WordPad, Notepad, and so forth, or in the ArcGIS Python window like we did in our previous exercise. However, IDEs, integrated development environments, have more to offer. So they have interactivity. You can write, save, and run scripts as well as using it in interactive mode. They do color coding, so you have the meaningful elements of Python are colored for you, and you can use tab completion, so you start typing something and it may help you finish it. And syntax checking and of course debugging are available with standard IDEs. So in this class we go over Python Win and PyScripter a little bit, and those are good for Windows. If you want to work with Python on a Linux, we can recommend PyCharm, Wingware. PyCharm is actually also available for Windows, as well as IPython Notebook, which is an online development environment. The Python Win interface, it's the very easiest one to learn. It doesn't have a lot of bells and whistles, and you can just pick it up really quickly. So we have the scripting window, which is where you write code that you want to save and use for later. So that'll be saved, and you come back to that machine where you've saved it and you'll find it again. The interactive window, as soon as you close the interface, that code that you write in here is gone. But this interactive window is really great for testing single lines of code, testing little chunks of code, and seeing the results right away. And all of our IDEs are going to have an equivalent, a scripting window and a place where you have interactive activity like an interpreter window. Finally, we have the feedback in Python Win, which I'm making a big point of, because the feedback window sometimes gets missed. The feedback bar sometimes gets missed because it's down there, kind of subtle. So you may run your code and think nothing has happened, but actually you've got a message that says there's a syntax error or something else. And if you run your code and it's successful, you also get feedback down here. There's a toolbar in Python Win, which has standard stuff. It's just similar to a word processor. You have a new button, and open, a save, and then you get into other stuff. The running the script is used, the little running man is used to run the script, and this is used for checking the code to see whether it's even going to run in the first place. The interactive window that we looked at in the previous slide, that you can toggle on and off with this button. And so this table gives you some other shortcuts and so forth. Let's look at a code example one line at a time. really simple program that adds two input numbers. Two numbers that are input by the user. So first line of code is a comment. It has the number sign in front of it. So that means that it's going to be used only by human readers. The Python interpreter itself is going to ignore any lines of code that are comments. Next we have a line that says import sys. And the import sys line is giving you access to anything that's in the sys module. Sys module is another script that's on your computer that's installed when Python is installed. It's a built-in module. So on the next line, where we have a equals int sys argv1, we're using the sys module. If we hadn't used import here, we couldn't use the sys down here. So what we're doing with A, B, and C is we are creating variables. Variables are assigned a value with the equal sign. So whatever's on the right goes into that variable, and it points at that location in memory. So on this line, I don't know where my mouse went. On this line, the sys.argv1 has this argv thing. This stands for argument vector. A vector is a list. You can think of a vector as a kind of a list. And this argv is the list of things that are sent into the script by the user. So when you run the script, you'll find that if you click on the little running man, it'll launch this run script dialog, and it will ask you, there'll be a blank here, and you can fill in whatever you want in this blank. We've put the numbers 2 and 3 separated by a space, so it'll take 2 separate from 3 instead of reading 23. So what happens is the script takes the first element in the input by the user, and it's going to assign that value to A. Well, first of all, it's going to convert it to an integer and assign that value to A. So then A becomes the number 2, and then we get sysargv2. Can you guess what that's doing? It's almost the same line of code. This is finding the integer value of the second argument from the user, which is the number 3, and assigning that value to B. On the next line, we're adding the two numbers together and storing the value of the sum in the variable named C. On the last line, we're using that print statement that we used in our interactive exercise. And this is going to print the sum is, and in this case, what is that going to be? It's going to be C, which is the value 5. We have another in-class exercise. We practice running a script with Python Win, so you should have that installed by now. And if you haven't installed it, go over to the first assignment, and it explains there how to install Python Win and PyScripter. So we start with our installed Python Win. Click the running man, and you're going to run the script. So let's go over to the in-class page, and if you roll down a little further from your previous line, you'll find the add.py in-class exercise. So pause the video and walk through this exercise so that you have the answers to the questions that's posed at the end prepared, and then we'll go over the answer. I'm going to go ahead and save add.py. And open that directory. And then I'll say open with, you may have to browse to the program. I've already got it set up, but keep on using Python when.exe. And then if you can't find Python when, you may need to find the executable, which has this name, and then browse to and select that as the default for opening the scripts. Now we'll choose window, tile, and then we have both of our scripts. Let's make them a little bigger. Tile them again. We have both of our windows, the script window and the interactive window. So now we can run by either clicking Control-R or the little running man. And we're supposed to use, for the arguments, we're supposed to use 5 and 6. So that prints out the sum is 11, which is what we hope to see. So now we want to try the next, so we're now in step 8, uncomment the last 4 lines of the script by selecting them and clicking Alt-4. So you can, well, those other ones don't matter, but I won't do that. Okay, so Alt-4, uncomments, Alt-3 comments, except for the last line. You can also use right-click, source code, comment out region, but I find the unless the last line is not, if an additional line is not included, it doesn't get that last line. So let's uncomment those. That means that now the Python interpreter will look at them when we run it. Before they were commented out, so it was only human readable. So now we're going to run the script again. And it prints out sysargv1 plus sysargv2 equals 56. And then it prints out the sysargv0, 1, and 2. So interesting, right? Because it thinks that 5 plus 6 is 56. Can you explain that? Also, can you explain what is this? What do we think sysargv0 is? So if we go back to our slides, we have the synopsis. It says the sum is 11. Good. Then we say the sum is 56. So why is that? Well, that is because the Python, when you pass it in, when you pass anything in, it interprets it as text, not as numbers. Specifically, it interprets it as strings. So we have the string 5 plus the string 6, and when you plus two strings, all it does is put them together. It's called concatenation. So it makes the result 56. And the difference between this sum and this sum was that for the first one, we cast them to integer. We converted them to integer before putting the plus sign between them. So then it does math with the plus sign instead. Now the other difference or the other question that arose is, what is argument vector 0? Well, argument vector 0 holds the path of the script that we're running in. So the current directory for the script, the full path file name for the script is always the first argument in the argument vector. The user doesn't pass that in, but it's in there anyway. And so notice that the argument vector is 0 based. It starts with 0 and counts upward. And this first thing is always the path of the Python script. Okay, so that was our simple add.py. We got to look at a few of the components.